Now, according to the definition, the difference between loudness of the given sound and the faintest sound is called the intensity level or the sound level. So the difference of the sound, the given sound, and the difference of the faintest sound is called the sound level. So basically this is the sound level, or more precisely, when we take it take the k common, we get log of I minus log of I naught. Now it is the rule of log that when two logs are subtracted, it can be written in the form of log as division. Okay, so log of I minus log of I naught would be equal to log of I over I naught. It is the rule of logarithm. You must have studied in your mathematics class. Okay, so sound level becomes k log of I over I naught. Now we'll discuss what exactly is this log thing. Why do we take log? Now students, we know that the faintest sound, the sound of faintest loudness is equal to I naught equal to 10 raised to power minus 10 watts per cubic meter. Okay, this is a really faint sound. If we take 1 watt, okay, we take 0.0000000000001. Here we have this amount of watt, and on the other hand we have 1 watt. 1 watt is the threshold sound, the threshold loudness, the loudness at which we will start to suffer from pain. So we take it as the upper boundary. The other boundary is 1 watt per square meters. Okay, so at one end we have this small sound as compared to 1 watt per meter square. It's just like if we have 1 meter square of the area and we have 0.000000001 watts in this area. Okay, so these two terms are very much different. There is a huge difference between this and this. There is a huge variation between this and this. So what does log do? What is the purpose of log? Log converts huge variations into standardized numbers. Okay, so when we take log of I over I naught, it means that we are converting this much variations, which are very difficult to calculate, into something very easy and simple. Suppose we have log of, or just don't put any, you'll get confused, log of 1,0,0,0,0 here. You will also see this example in the video I'm going to give you. Okay, so what would be the power of 10 to get this much value? Okay, this is a very huge value. It should be 5. So log of 1,0,0,0,0 is equal to 5. This is what logs do. Log turns very huge variations into simple numbers. Okay, that is why we take log here, because we have very high upper value and very low lower value. Okay, That's why we take log here. Now, what would be the value of k? There's a condition for it. When I, the given intensity of sound, when I equals to 10 times the faintest intensity, then k equals to 1. And the sound level will be 1 bell. 1 bell is the unit of the intensity level of sound. But more conveniently and generally, we do not use bell generally. We use decibel. Okay? So if we take bell and multiply it by 10, we will get decibel. There's just the difference of 10 getting multiplied here. Here we had this one in bells. We multiply it by 10 and we get decibel. This is the most commonly used unit of sound level or intensity level. So this was all we needed to learn about intensity of sound. Moving to our next characteristic, which is quality of sound. Okay, so quality of sound. Students, I think if we have a wave, a sound wave, two sound waves, which have same amplitude and same frequency, then how will you distinguish between this sound and this sound? What is the parameter used to distinguish between these two? The parameter used to distinguish between these two is called the quality of sound. Quality of sound in simple words. The quality of sound in simple words is that the the property by which we distinguish two waveforms by their formations. Okay, these two are the same. Now, if we have wave drawn like this, and if we have another wave with this with the same amplitude and the same frequency but different wave form. Suppose we have a wave like this. Okay, it has the same amplitude and it has the same frequency like this one, but there is a difference between these two waveforms. Okay, this is how you will determine the quality of sound. This one has more variation in its waveform, and this one is just a simple wave all along. Okay, and also we can have another example of square waves. What are the square waves? These are the square waves. Here also the amplitude is same, the frequency is same, but the waveform is different. The property of sound by which we distinguish between different waveforms of sound is called quality of sound. Thank you so much, everyone.